Not very long ago, we thought we were alone in the universe. Yes, we knew about the planets in our own solar system, but had no direct evidence of worlds around other stars. That all changed in 1992 with the discovery of several terrestrial mass planets orbiting a pulsar. Pulsars are high-energy objects and certainly not a home for life, but it was a start. Since that first detection, the pace of discovery has accelerated, with the current number of confirmed exoplanets set at 4,704 as of April 1st, 2021. In this video, we'll take a closer look at these distant worlds, how they were formed and discovered, and what it means for the future of mankind and life in general. 4.6 billion years ago, our own solar system was formed, the result of the collapse of a giant cloud of rotating gas and dust. Most of the material went to form the Sun, but the leftover material from that process formed the planets, asteroids, and comets. It stands to reason that there's nothing unusual about the process, and that most stars will form that way. The discovery of exoplanets confirms this. You can't build a house without a lot of trash being left behind, and it seems the same is true for the stars. Our first tool in the discovery of exoplanets is simply gravity. A star's intense gravitational field keeps a planet in orbit, but a planet has a gravitational field too. The planet's tug on the parent star causes a slight wobble in the star as the forces balance out. It's this change in position that can be observed and measured. If the mass causing the wobble is calculated to be small enough, you've just discovered a planet. This method works well for nearby stars and large planets orbiting very close to the parent star. But to discover Earth-sized planets that are orbiting within the habitable zone requires a more sensitive method. Luckily, we can use the star's own light to do just that. If a planet's orbital plane is oriented so that it passes in front of the parent star from our point of view, the star's brightness will drop. Think of it as a very tiny solar eclipse. If your detector is sensitive enough, this eclipse can be seen in the star's light curve. The depth of the dip tells you how large the planet is, and how long the dip lasts tells you how large the orbit is. This method is effective out to more than 1,000 light years, and is limited only by the size of the telescope and the sensitivity of the detector. With the help of microlensing events, planets have been suggested as far away as 3.8 billion light years. Now that we know that exoplanets exist, and we know exactly where to look, we've been able to directly image some of the brighter examples that have very large orbits, confirming directly that what we are seeing are indeed planets and not some kind of exotic object. Through these discoveries, we have learned that the exoplanet zoo is very diverse, ranging from objects smaller than the Moon to objects 20 times the mass of Jupiter. So large they are crossing the boundary between true planets and brown dwarf stars. But what about habitable planets? Worlds a little smaller or larger than our own, with an Earth-like atmosphere that orbits the parent star at just the right distance so that water is liquid all year long. So far, only 45 such planets have been confirmed, but if you consider that the Milky Way galaxy contains somewhere between 100 and 400 billion stars, the possibilities are mind-boggling. By some calculations, there are enough Earth-like planets in our own galaxy to provide one for every man, woman, and child on Earth today. And that's just our galaxy. The universe contains trillions, more than enough for a home for you and me.